Hello everyone, hope you're all doing well. Thank you so much for watching my videos. This video is in a series of videos where we are talking about machine learning foundation concepts. Last video we talked about three levels. The three levels were first the manual level, the second was the programming level, and third was the machine learning level. Okay, and we also decided that manual level is completely out of the picture because all the notebooks and everything registers, it just cannot scale to a very large amount. So this is gone. So we have left it programming and machine learning. Programming, we told to a certain extent it is acceptable, and we wanted to understand why we actually need to go to the machine learning level. So in this video, what we will talk about, why we actually need the machine learning rather than why can't we be happy with the programming. Okay. So why ML? This is what is the topic of the video, what we are going to look at, and what we are going to see is the no rules problem. It looks very technical jargon or something like that, but as we progress in the video, you'll understand it's a very simple concept where what we are talking about, why the no rules is very important for the machine learning methods. Okay, so that is what we are going to do, differentiate machine learning from programming. Okay, why do we bother with machine learning if programming is faster? We're talking programming is faster. Why programming is faster? Because programming is very linear kind of thing. Sorry for my line. This is supposed to be my line. I'll try to do a better line. I think this is a better line. This is straight line. So basically, programming is like a straight line. So if there is there is two inputs, you will get an output here. Okay, so if there is A plus B, we are going to get C. Okay, so this is very straightforward, and every line of code can determine certain output what we can get, and it is 100%. It can be repeated 100 times, and you will get the same result. Okay, so it's a very straightforward thing. So it becomes very easy for coding, and that is why it becomes faster in some sense. Where programming, in case of smaller databases, and where the data things are very less, programming is very helpful. Okay, but what we are talking about here is why we bother with machine learning, because of these three big reasons. What we are looking at will be the requirement of having to look at the possibility of using machine learning in our day-to-day life. Okay, when is machine learning actually needed? First is a scale. Again, if there is a huge amount of data, we are not talking about hundreds of thousands, we are talking about millions and billions and trillions of data. You can imagine the amount of data we are creating in each and every action of ours. If you open a Google map, you are traveling from A to B, maybe from 10 kilometers, you can create hundreds and thousands of data points in that one movement of your Google map from A to B. So if you have the amount of data you need to analyze, the programming will seriously fail. Okay, you cannot use program for analyzing millions and trillions of data. Okay, so in that case, the programming will fail. Speed. It might be you feel it is counterintuitive. Last slide only we talked about programming is faster and machine learning is slower, but why we need the machine learning? So what we are talking about are two different, what do you say, stages of the same data collection analysis process, where we are talking about the speed. The first one where programming is faster is where we have the clear output. Okay, but where we are talking about in machine learning is once you have this formula derived by the machine learning algorithm itself, after which it becomes faster, because initially the machine learning is very slow. Okay, so when we talk about speed in case of programming, I told you this is a straight line. If you put a here, b here, you will get a c here. But in case of machine learning, it is an area. So you have to give many inputs here for it to get only one output. For getting one output, you have to give in many outputs, many inputs. Sorry. So then you get the output. How it gets? You don't get this directly. You have the machine learning model which learns from the inputs what you give, and then it learns the formula, and then it gives the single output. Okay, so that is how the program gives the answers. It is not a straightforward programming thing, and you cannot write a code directly to get what we do is we have various codes writing for this machine learning to learn from the data. We give the data to the machine learning algorithm, and then it gives that to the output. Okay, that is how we do it. So speed wise, once you have the machine learning, then it becomes very fast, because where you give a data here where we talked about in the programming what we talked about, like you have this a and b, you will get c. But if you give our input here, the programming will fail because it doesn't know where to go, right? But in case of machine learning, where it has such a big area, so even if the any number of changed questions also you give to it, the machine learning will live and give you the correct output. Okay, the output can be here, the second output can be here, the first input can be here, the second input can be here. It will automatically give once the formula is fixed. Okay, this formula here, the programmer does it manually, the machine learning learns it from the data. That is the difference between programming and the machine learning. Cost. Again, this is a very touchy area where we already are seeing we understand a lot of jobs being lost because of AI. So this very straightforward, I feel, where we need, if you have a program and you need to change the program for any reason, you need to change the program because there can be a lot of changes in the data, there can be a lot of changes in the demographic. So there can be so many changes. Even the clients can keep on requesting more and more changes. So in that case, programming has to be written again and again and again. Hence, this involves, and again, programming means the developer has to be there, and there are hundreds and thousands of support staff who actually are needed for supporting the software which needs to be run, right? So we have a lot of support staff required for maintaining the operation of the software. But in case of machine learning, the machine automatically takes care of most of the data tasks which are repetitive, where the support staff is required. All the support staff can be again replaced by AI, and hence the cost is done at a marginal level. These are the three main areas where need machine learning, and programming will not be able to cope up with the requirement. What we are talking about in the first heading, I told you, no rules problem. Okay, so what I have been discussing, the single line and the area. This is where the no rules come. Okay, here you have a very fixed rule. If you give this input A and B, you will get C. There are very fixed rules. Here you cannot give any specific rule for it to get the output. The machine learning, because why we cannot give the rules? Because the data, the examples which we are giving are so diverse that it is humanly not possible to get a formula for which the machine learning itself learns. For we can write and then give it to machine learning for it to give the output. Hence the no rule problem. The what is meaning of the no rule is inability to express rules using language. If I have to express a password, which we will see in the next slide, you will be more clearer. We will go to the next slide and see what we have in the next slide. When machine learning succeeds, lots of example data. You have lots of example data. Machine learning will succeed. As I told you, if you give less number of inputs here, it will be very difficult for the machine learning to learn. Okay, so it will fail. So you have to give many examples for the machine learning algorithm to learn. Okay, have structural idea on the rules. Have structural idea means, for example, if you are going to give the data, we are going to give the examples here. For example, we are giving data examples of animals. Now we are giving examples of furniture. The machine learning algorithm will get confused. It will not be able to find out if we want to develop a program of identifying animals, and we are giving examples of animals. Okay, it will help machine learning to understand animals, but if you give furniture, then it will get confused and it will not be able to give you the correct output when we require. Okay, so we have to have a structural idea on the rules. We have to have, even though we don't have any rules, but we have to give we should have an idea of what examples we are going to give, so that the machine learning will give the correct output as per our requirement. Okay, again, what I mentioned is inability to express rules using the language. Password versus face. This is what is where the machine learning is differentiated from the programming. Password is programming, face is machine learning. We have a program, we feed the password and you just save it in the database. So as soon as the user comes and enters the correct password, you log in. But in case of face, how are you going to save the face in the code? Which is almost impossible, because even the face itself keeps changing every day. You can have some makeup, you can have eyes closed, you can have eyes open. It is impossible for the programmer to write a program to identify a face for a password. That is where we need machine learning. Password is good for level 2. Level 2 is program, as we saw, but face needs level 3. Okay, face recognition needs machine learning. That is where the difference between programming and machine learning. So in this video, we have seen where we need machine learning, why we need machine learning, and where all the machine learning can have success. Okay, where programming will fail. Okay, let us end this video here, and I will not take much of your time. Let's meet in the next video, where we will deep dive in this difference between password and face and see how it goes. Thank you so much for watching till here. We'll see you in the next video. Take care. Bye-bye.